Hi, I'm Jose Esposito, one of the authors of this book. Some people have asked me to explain and to talk more about the implementation of a compositional grading problem, right? In a computer language, for example. Okay, so today we're going to talk a little bit more about the implementation of the most common compositional grading problem. The 1D non-isothermal system. Okay, let's go. Well, here's the equation of the diffusion flux, the only one that remains, okay, when you're dealing with a 1D system. So this is the Fick's law, and this is the diffusion coefficient, the molecular diffusion coefficient. Okay, this is the temperature gradient term, the thermal diffusion term, the most important one. This is the thermal diffusion coefficient. And this is the pressure diffusion coefficient, right? So we have already demonstrated that Ji is equal to 0 in such a problem, okay? So we're going to solve this equation along the depth of the reservoir, the z direction, okay? Our variables are the mass fraction, okay, and the pressure, right? So if you start at the reference level, let's say the level 0, okay, and you have to calculate the pressure and composition at the next level, level 1, for example, okay, m equal to 1. Okay, this is the equation you have to solve, say, for example, by Newton-Raphson's method. Okay? So, if you want to solve this equation from Newton-Raphson's method, so you will have to write the variable updating in terms of the Jacobian of this function. Okay, so suppose you have the initial guesses for the compositions, the mass fractions, okay, that you're going to use here, and pressure. So you have the temperature field. So you have temperature, pressure, and composition, right? The gases of pressure and composition at the next level. And you will update the mass fraction by a Newtonian iteration, just like that. Okay, when you update the composition, you use the new composition at the level of interest, right? The level for which you are calculating the pressure and compositions. You update the pressure from this equation here, which is the hydrostatic relation, right? And once you update the pressure here, you come back to the Newtonian iteration to update the composition again. Then you update density. Then you update pressure. Then you come back here to update the mass fractions. Okay? So, it's just one way to do the calculations. Okay? And you have to do this task for every level that you consider from the reference one, right? Say m equal to 1 and the reference level is 0, right? So you solve everything for level 1. Then once you get pressure and compositions for level 1, you redo everything for level 2, level 3, and so on. Okay? Well, I'd like to talk to you more about some important issues that we're dealing with here. Well, this problem, it is described on page 115 of the book. And unfortunately, there are some typos there I would like you guys to notice, right? So this is very important. It's not D here. we have W here, sorry. We have W here, okay? The matrix W. So here it's not D, it's W. And here it's not X, not the mole fractions. We have the mass fractions here. Okay? Okay, let's move on because unfortunately there are other typos here. There's no subscript J here. There's no subscript J here. It doesn't make sense for temperature. It doesn't make sense for depth. Okay, so please pay attention to page 115. Okay, one of the most important problem descriptions. There are some typos there. I've already identified them. Please take a look at them and fix it in your book. So we'll try to fix that on the second edition. Okay? Thank you very much for your attention. And well, if you want to know more about compositional grading, please take the book. If you find some more typos or something like that, we'll be happy to fix them, right, with your help. And we'll try to make a better job on second edition. Okay, thank you so much. See you.